Hey guys, welcome to my channel Chemistry Catalyzer. First of all, I would request you to please subscribe my channel and I have a target for 1,000 subscribers. Now let's get back to our topic. Today's topic to discuss here we have is hybridization. Hybridization is so interesting and charming topic. You would be amazed to listen this lesson from me. Hybridization simply means to mix up. Now remember its meaning, and it would be easier for you to remember this topic. Now, first of all, the definition here we have. I would hope that you would be familiar with the term orbital. It is actually the space where the probability of finding the electron is maximum around the nucleus. So, hybridization simply means to intermix the orbitals, which orbitals would have slightly different energies and they would have indeed different shapes. So when these orbitals intermix with each other, they form new orbitals according to the hybridization concept, and these orbitals would have same energy and would be called as hybrid orbitals, or we can more precisely say them in chemistry degenerate orbitals. Alright, these degenerate orbitals would have specific geometry and they would have same shape and similar bond angle, and hybridization will lead to the formation of entirely new shapes.
Let's take an example here for the sake of easy to understand. Suppose that we have a bowl of milk and a bowl of sugar and another bowl of slices of mangoes. Now, all these bowls have three different things having different energy and indeed different shapes. When we'll put them in a grinder, it will grind them up and we will have a new thing which would have same shape, same energy, and no matter how much you put them into the bowls, these would have same shape, same energy. Same is the case with the hybridization. Before hybridization, you have orbitals of different shapes and different energies, but as the hybridization proceeds, that is the grinding proceeds, right after hybridization, it will give you new orbitals which would have same shape and same energy.
Here I would tell you the shapes, geometries and angles formed as a result of hybridization of different orbitals. The number one shape we have here is sp hybridization. I am moving from quite simple shapes towards complicated shapes. So first of all, we have sp hybridization. It is formed by mixing of one s and one p. It could be px, py or pz orbitals, and they would form two new sp orbitals, and these two new sp orbitals would have linear shape and have bond angle of 180 degrees between them, and this would be the shape as a result of sp hybridization. You just have to remember this shape, and it is one sp orbital and this is another sp orbital, and the bond angle between them is 180 degrees. Now, next shape we have is sp2 hybridization. As a result of sp2 hybridization, which would be formed by combining or intermixing of 1s and 2p orbitals, and they mix up to form 3 sp2 hybridized orbitals, and these 3 sp2 hybridized orbitals would have same energy. We used the word degenerate orbitals for these orbitals, these three orbitals, and the shapes for these three orbitals would be trigonal planar, like a triangle, three corners, and it would be in the plane of paper. Planar means in the plane of paper. It would have bond angle of 120 degrees. Now this is actually the shape These are three orbitals: sp2 orbital 1, sp2 orbital number 2, and sp2 orbital number 3, and it has shape of triangular planar, trigonal planar or triangular planar. Here you can see it from here. All right, next we have is sp3 hybridization. It is formed by mixing of 1s and 3p orbitals, px, py, and pz, 3p orbitals, right, and they would form 4 new sp3 orbitals which would have same energy, and the shape of these 4 orbitals would be tetrahedral, and the bond angle would be 109.5 degrees. And this is the shape. You can see it is a tetrahedral structure: one sp3 orbital, another sp3 orbital, another sp3 orbital, and the last one sp3 orbital. Right, it is actually a tetrahedral shape, yeah, like this and this. And the bond angle between each orbital is actually 109.5 degrees. The next shape we have is dsp3 hybridization. Now we can see here a d orbital is also involved, and from here you can see that 3p orbitals, 1s orbital, and 1d orbital intermix to form wholly new 3, 4, 5 orbitals, which would be called as dsp3 orbitals, and it would have shape of trigonal bipyramidal. Trigonal from previous sp2 hybridization we have here is a trigonal shape. It's quite a bit tilted, and bipyramidal, you can see a pyramid right here and another pyramid right here. Bipyramidal, 2 pyramids we have here, and the angle would be 90 degrees and 120 degrees. 120 degrees would be between these 3 orbitals which are in trigonal planar, and 120 degree would be the angle 90 degree would be angle between these 2 orbitals, bipyramids. These are perpendicular to each other. Next hybridization we have here is d2sp3 hybridization. 3p orbitals, 1s orbital, and 2d orbitals intermix to form 2, 3, and 6 new orbitals. 6 new orbitals we would have here in our shape, and this shape would be known as octahedral, and the angle between each orbital would be of 90 degrees. This is octahedral shape. I could form a rectangle from these 4 orbitals, and another, these 2 lines, and these 2 lines. It is an octahedral shape. Alright, and in order to draw, one thing to remember here is, in order to draw the hybridization structure, you should learn all these 5 structures. We actually have one more hybridization, but it would be in case of transition metals, and which is dsp2 hybridization. Its shape would be square planar. And you can see from here that 2p orbitals, 1s orbital, and 1d orbital would intermix to form dsp2 hybridization. And it would have a shape just like here I'm making 4 orbitals we have here, 1, 2, 3, 4 orbitals, and so square planar shape would actually have 4 orbitals, right, like this. You can just link these to the center. So that it will show the bond between the central atom and the subsidiary atoms, which would be attached here. and this each balloon type structure is showing one orbital of the central atom. This is actually a balloon type structure. Well, now to have a glance at an example, at a simple example, I'll show you how to draw a hybridized structure. Now here we have a methane molecule. Now it is a central atom we have, and 4 hydrogens are actually subsidiary atoms. First step is to write down the ground state of carbon. Ground state of carbon is actually a simple electronic configuration: 1s2, 2s2, and 2p1, 2px1, and 2py1. 2pz is actually empty orbital, and we have to attach 4 hydrogen atoms, but here we have only 2 lone electrons in these 2 orbitals, so we need another 2 lone electrons for attaching the 4 hydrogens. So in order to get 4 electrons, we would excite 1 electron from s orbital to the pz orbital. The excited state of carbon would be just like this. 1s here we have, it's just we don't matter from this. Excited electron, it would be the lone one here, and excited electron would go into pz orbital. So here we have now 4 lone electrons to form bond with 4 hydrogens. But before forming the bond, carbon will undergo hybridization state to make these all orbitals of same energy having same shape, which would lead to the hybridized state of carbon. And here we have 4 new hybridized orbitals named sp3 orbitals, each having 1 electron in it. So we would draw a tetrahedral structure having 4 orbitals, having 4 new sp3 orbitals, and the 4 subsidiary hydrogens orbitals are forming overlap with these 4 sp3 orbitals, and in this way our hybridized structure is formed. That's it, dear students. That's all for today, and I'll make another video to show a simple trick for determining the hybridized state of any molecule having charged or simple neutral molecule. So subscribe it and comment below any question you have in your mind. Freely you can ask any question freely without any hesitation. You don't got any point, or any point you were not clear about, you can freely ask it in the comment section. Please do subscribe to my video so that I may make more videos to simply teach you chemistry. So long, take care, and goodbye.